Problem set 1, question number 8. We will discuss this question once again. Here, this segment SD, segment RC, segment QB and segment PA are perpendicular to same line AB. As these segments are perpendicular to the same line, therefore these four segments are parallel to each other. Okay. So, we will consider now PA is parallel to QB is parallel to SD. See these three lines. Okay. Then we can write PQ upon QS is equal to AB upon BD. But PQ is not given and QS is also not given. Whole PS is given as 280. If we write PQ as X, then QS will be this 280 minus X. It will be 280 minus X. Okay. So we will write now X upon 280 minus X is equal to this AB is 60 and this BD is 70 plus 80. It is 150. So it is X upon 280 minus X equal to 60 upon 150. See here. X upon 280 minus X is equal to 60 upon 150. 0, 0 will get cancelled, or dividing the numerator and denominator by 10. 3 2s are 6, 3 5s are 15. By cross multiplication we can have 5 into X is equal to 2 times 280 minus X. Okay. So 5X as it is. This 2 into 280 is 560. This 2 into X is 2X. Minus 2X will come to this side and will become plus 2X. 5X plus 2X is 7X. 7X is equal to 560. Then X will be 560 upon 7, that is 80. X is 80. That means this PQ is 80. Okay. As this PQ is 80 now, this QS will be 280 minus 80, that is 200. This QS is 200. Now we will write this QR as Y. Okay. As QS is 200 now, RS will be 200 minus this Y. This QS is 200. RS will be QS minus QR, that is 200 minus this Y, that is 200 minus Y. Then by property of three parallel lines and their transversal, we can write Y upon 200 minus Y is equal to 70 upon 80. See here. Y upon 200 minus Y is equal to 70 upon 80. Dividing numerator and denominator by 10, we can have here 7 by 8. By cross multiplication, we can have 8y is equal to 7 times 200 minus y. So 7 into 200 is 1400. 7 into y will be 7y. Here it is. Minus 7y will come to this side and become plus 7y. 8y plus 7y is 15y. 1400 as it is. This 15y is equal to 1400 now into 15 will go to that side and will become upon 15. So y equal to 1400 upon 15. Now 5 3s are 15, 5 2s are 10, remains 40, becomes 40 becomes 40, no? So 5 8s are 40, 5 zeros are 0. Okay. So y is 280 by 3. Y means this PQ is 280 by 3. Now RS will be QS minus QR, that is 200 minus this 280 by 3. See, RS is QS minus QR, QS is 200, QR is 280 by 3. So 200 into 3 is 600 minus 1 into 280 is 280 upon 3 into 1 will be 3. 600 minus 280, that is 320 by 3. Okay, so PQ is 80, QR is 280 by 3 and RS is 320 by 3. Next question number 9. In triangle PQR, segment PM is median. this PM is median. That means we can conclude that QM equal to MR. And bisectors of angle PMQ and PMR intersect side PQ and side PR in points X and Y respectively. See, these bisectors of these angles are intersecting the sides in points X and Y respectively. Then we have to show that this XY is parallel to QR. Now we can have by angle bisector theorem, as ray MX is angle bisector or bisector of angle PMQ, then we can write this PM upon MQ is equal to PX upon XQ. In this triangle PMR, we can write PM upon MQ is equal to PY upon YR. So by angle bisector, divide the opposite side in the ratio which is equal to ratio of remaining two sides. That means PY upon YR should be equal to PM upon MR, or PM upon MR should be equal to PY upon YR. See here, same thing we are writing here. This PM upon MQ is equal to PX upon XQ in the first statement, and in second statement PM upon MR is equal to PY upon YR. This problem is given as activity, you have to fill in the blanks only. Now this MP and MP is same, this MQ and MR are different here. Let us see what is MQ. See, this MQ and this is MR, but they are congruent because PM is median. It bisects the segment opposite to it. Okay, no? So what is the definition of median? Median is the segment which joins the vertex and midpoint of the side opposite to it. Okay, so this is the midpoint, then QM equal to MR. As QM and MR are same and MP and MP is same here, we can write MP upon MQ equal to MP upon MR. But this MP upon MQ is equal to PX upon XQ, and this MP upon MR is equal to PY upon YR. See, PX upon XQ. See here, PX upon XQ is equal to PY upon YR. Then by converse of basic proportionality theorem, we can write that line XY is parallel to line or segment QR. Okay. Simple thing. Once again, see here, this PM upon QM is equal to PX upon XQ. This PM upon MR is equal to PY upon YR by angle bisector theorem. In both the ratios, this PM is same thing. What is different is MQ and MR. But MQ and MR are congruent because PM is the median. Therefore, PM upon MQ, as it is equal to PX upon XQ, and PM upon MR, which is equal to PY upon YR, will also be equal. That means we can write PX upon XQ is equal to PY upon YR. If these two ratios are same, then we can say that line XY is parallel to side QR by basic proportionality theorem. Now question number 10. In figure, bisectors of angle B and C of a triangle ABC intersect each other at point X. See, these bisectors are intersecting each other at point X. All the values are given here. AB is given as 5, AC is given as 4, and BC is given as 6. This BC, whole thing is given as 6. Then you have to find out the ratio X upon XY. This ratio AX upon XY, you have to find it. As a BX is a bisector of angle ABY, then we can write that AX upon XY is equal to AB upon BY by angle bisector theorem. Okay, see here, AX upon XY is equal to AB upon BY. As this ray CX is bisector of angle ACY. Therefore, by angle bisector theorem, we can write AX upon XY equal to AC upon CY. Okay, see here, AX upon XY is equal to AC upon CY. By observing the two triangles, by applying the angle bisector theorem, we can have these two statements, statement number 1 and statement number 2. But in both the statements, X upon XY is the same thing. So we can write X upon XY is equal to AB upon BY is equal to AC upon CY. Now, we have already learned that if A upon B equal to C upon D, then by theorem on equal ratios, we can write as each ratio as A plus C upon B plus D. So we will use same property here. If these ratios are equal, then each ratio should be equal to this numerator plus numerator upon denominator plus denominator. AB plus AC as it is, but BY plus CY. See, what is BY plus CY? BY plus CY is nothing but BC. Okay, so BY plus CY is BC. This is the different step we have done here. See here, once again, AX upon XY is equal to AB upon BY, that is equal to AC upon CY. By theorem on equal ratios, we can write each ratio equal to numerator plus numerator upon denominator plus denominator. But BY plus CY, according to the figure, by observing the figure, BY plus CY is BC. Now we can substitute the values. This is 5, this is 4, and BC is 6. 5 plus 4 is 9. 9 upon 6. 3 3s are 9 and 3 2s are 6. The ratio AX upon XY is 3:2. Okay. Now, this question number 11. In quadrilateral ABCD, segment AD parallel to segment BC, diagonals are intersecting in point P. Then show that AP upon PD equal to BC upon BP. AP upon PD. Let us see what is where is AP. This AP upon this PD is equal to PC upon BP. This PC upon BP. This PC upon BP. Okay. By observing the sides, we can conclude that if we can show that these two triangles are similar, triangle APD and triangle CPB. If these two triangles are similar, then we can write corresponding sides are in proportion, and then by cross multiplication only we can have the answer, or any other operation we have to perform. Let us see, in triangle APD and triangle CPB, correspondence should be, as these two lines are parallel, therefore this angle A is going to be congruent with angle C, and this angle D is going to be congruent with this angle B, and this opposite angles are congruent, therefore P is one-to-one correspondence with P only. So if you are writing APD, then you should write CPB. Okay, because A is going to be congruent with C, alternate angles, and this D is going to be congruent with B, same thing, alternate angles, and P is going to be congruent with P, opposite angles. But we are going to show only two angles. In triangle APD and in triangle CPB, angle DAP is congruent to angle PCB, alternate angles. As given this AD is parallel to BC, then alternate angles are congruent. Angle ADP is congruent to angle PBC. Once again, alternate angles. See here. As two angles are congruent, therefore these triangles are similar. Okay. So triangle APD similar to triangle CPB. Then corresponding sides are in proportion. AP upon CP is equal to PD upon PB is equal to AD upon CB. Okay. What we want is AP upon PD. Is there AP upon PD? Yes, in these two ratios we can have AP upon PD, but we will once again consider this ratio as AP upon CP is nothing but PC, PD upon this BP. By alternando, what is alternando? If A upon B is equal to C upon D, then by alternando we can write A upon C is equal to B upon D. That means this numerator upon numerator should be equal to denominator upon denominator. So AP upon PD should equal to PC upon BP. AP upon PD should be equal to PC upon BP by alternando. Hence the proof. Okay, what we have done, these two triangles we have shown it similar by AA test, these alternate angles, and therefore by AA test two triangles are similar, therefore sides will be in proportion, and last thing we have done alternando. Okay, now question number 12. This is also activity. Here xy is given as parallel to AC. This is the xy which is given parallel to AC, and 2ax is equal to 3bx. We have to complete the activity to find this AC. As 2x is given as 3bx, this 2ax is given as 3bx. Therefore, ax upon bx is equal to 3 upon 2. See, this into 2 will become upon 2. Now, by componendo, we can add numerator and denominator, and denominator will remain as it is. That is equal to 3 plus 2 upon 2. Componendo means you have to add numerator and denominator and write it in the numerator, and denominator remains as it is in the componendo. Okay, see here, if A upon B is equal to C upon D, then we will write A plus B upon B and C plus D upon D. It is equal to C plus D upon D. So here it will be 3 plus 2 upon 2, that is 3 plus 2 is 5, 2 as it is. The answers given in the textbook, here it is 3, it is a misprint here. So here it should be 2. Okay. Now they are directly given as triangle BCA similar to triangle BYX. By A test we have to write only A here. We can see how they are similar. BCA, see this BCA which is similar to BYX. Why it is? Because BCA, this angle C, and BYX, this angle Y, these two angles are congruent because they are corresponding angles. Also, this angle A in greater triangle and this angle X in smaller triangle, they are also corresponding angles. Therefore, by AA test, angle test, two triangles are similar. So we have to write only here AA test. Okay. Now corresponding sides are in proportion. Therefore, BA upon BX it will be. That should be equal to CA. That means AC upon XY. Substituting BA upon BX, we have got 5 by 2. AC as it is, XY is given as 9. This upon 9 will go to that side and will become into 9. So 5 into 9 upon 2 should be equal to AC. 5 9s are 45. 45 upon 2 is 22.5. So answer in the textbook is different because of this misprint. They have written here 3 by mistake. Okay. So keep in mind it should be 5 by 2, and answer because of that 5 by 2 it will come 22.5. Problem number 13. In figure, the vertices of the square DEFG are on the sides of triangle ABC. Angle A is given as 90. Prove that D square is equal to BD into EC. Vertices of the square are on the, these are the vertices of the square are on the sides of the triangle, and we have to prove that this DE square is equal to BD into CE. BD and CE are in triangle GDB and FEC respectively. If we try to show these two triangles similar, then we can get the answer. So, but these two triangles are not connected with each other. So we will take into consideration this triangle AGF also. In triangle AGF and in triangle DBG, I will say, because A will get congruent with D because they are 90. This A is given as 90 degree. As this is square, here it is 90. Therefore, this angle GDB will also become 90. This A and D are congruent because they are of 90 degree. This AGF is congruent with this B angle because they are corresponding angles, and therefore by AA test we can show that these two triangles are similar. Similarly, in this triangle AGF, in place of A now we will write this angle E. In place of this F we have to write angle C, and in place of remaining G we will write angle F. These two angles will be congruent because they are of 90 degree. This F is going to be congruent with this C because they are corresponding angles. Why corresponding angles are congruent? Because lines are parallel. Because this quadrilateral DEFG is a square, therefore DE is parallel to GF. That is, BC is parallel to GF, and therefore these corresponding angles are congruent. Okay. Now, by similarity of these three triangles, we can show if three triangles are similar, then they are similar to each other. Okay, by the property of the similarity of triangles, and then we can write these two triangles are similar, and then sides will be in proportion, and by cross multiplication we can prove the result. So let us start. Quadrilateral DEFG is a square, therefore DE is parallel to GF because opposite sides are parallel for a square, and therefore this BC will be parallel to GF. Now this angle AGF is congruent to angle B. See here, angle A is congruent to angle this GDB because they are 90, and this angle AGF is congruent with angle GBD because they are the corresponding angles. Okay, therefore these two triangles are similar. If you are writing AGF, then in place of A we will have correspondence with D, and G we will have correspondence with B. Therefore A if it is D, G if it is B, then we have to write AGF similar to triangle DBG. By AA test of similarity, two triangles are similar. Okay, these two angles are congruent with these two angles, therefore by AA test of similarity the triangles are similar. As now these two triangles become similar, we will try to show that these two triangles are also similar. This angle A is congruent with angle E, that is FEC, each of 90 degree, and this angle AFG is congruent with this angle C. Okay, AFG is congruent with angle C. Once again, they are corresponding angles. Okay, therefore triangles are similar by AA test. If you are writing AGF once again, then with this point A we have to get correspondence with this point vertex E, and if F and C are congruent, then this F should get correspondence with this C, remaining G will get correspondence with this F. Okay, now by 1 and 2, that means this is Roman 1 and this is Roman 2, these two triangles are similar, these two triangles are similar, and therefore AGF is similar to DBG, AGF is similar to EFC, and hence triangle DBG will be similar to triangle EFC. DBG will get similar with triangle EFC. Corresponding sides are in proportion. So dB upon EF should be equal to BG upon FC should be equal to DG upon EC. Now we want to get we have to get that D square is equal to BD into EC. So D square is not here. We should try for the next thing, that BD into EC. Yes, EC and BD are there. So we will write these two ratios, that is dB upon EF is equal to dG upon EC. BD into EC is equal to dG into EF. See, what is dG and what is EF? They are sides of the square, and DE is also side of the square. So in place of GD and EF, I can write DE. So in place of DG and EF, we will write DE, because quadrilateral DEFG is square. Therefore, D is equal to G is equal to EF is equal to GF. Therefore, the sides of square all are congruent. Therefore, in place of DG and EF, we will write another side of the square, that is DE. So D into DE will give you D square. So D square is equal to BD into EC. Hence the proof. Okay. So please revise this. This is the last problem of the problem set. We will try for the next chapter in the next lecture. Thank you very much. Thanks a lot.